Alright, let's start it. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Okay, we meet again in the financial data analytic class. And for tonight's session, I will take around 1 hour discussing on the new topics on the clustering, and the other hour for you to present your assignment on the CAPM, on the capital asset pricing model using the regression. Alright, so for tonight we are going to discuss about the financial data analytics using clustering. The objectives of tonight class is that you will understand the types of clustering, and then what is the k-means clustering all about, how to apply the k-means clustering in the financial data analytics, how to identify the distance between all of the coordinates, how does k-means clustering works, what is the k-means clustering algorithm or codings, and we're gonna have some demos on the k-means clustering onto the financial data analytics. Okay, so what is k-means clustering? K-means clustering performs division, separation of many objects into clusters which are similar between them and dissimilar to the objects belong to the other cluster. So on the k-means clustering, I think you already done this before in your digital marketing class or marketing management, when you perform clustering model, developing personas using SPSS. So in developing personas, we separate the objects into clusters where the objects within a cluster are similar to each other and dissimilar to the other cluster significantly. Yeah. The K is referred to number of cluster. Number of cluster. Means is the means. Yeah. The average. Yeah. So in k-means clustering, we separate the objectives into number of clusters and finding the means of the clusters. So here is an example. So we have some data sets. We have a data sets using X and Y. When you play, what we call it? Not American football, the softball. Softball, yeah. So there is the activity, there will be run and wickets, yeah? Hitting the ball. Run, hit the ball and runs. Yeah? Okay. So there is some y and x and y coordinates of people who do good week and low runs, yeah? And then low performance of weeking and high performance of running. So they hit badly, but they run very fast, or they weak badly, but they run very good. So there is some data sets. And from these data sets, we can separate it into two clusters. Cluster number one, we see that this cluster have players with high runs and low wickets. So this cluster, these people, they are good at running, but not good at wickets. Cluster 2, we see that this cluster have players with high wicket, but low run. Yeah? They have high wickets, but low in running. So in the K-means clustering, we separate the data where the objects of the data within a cluster is similar to each other. Yeah? And it is significantly different to the other cluster. So how did the K-means, how did the cluster develop? So initially, we need to identify the centroid of each cluster. The centroid. Yeah? But first of all, we assign it randomly. We put it randomly. Okay, let's get some random centroid. Yeah? And then we conduct Euclidean distance to find out which centroid is closest to its data point. And the data point are assigned to the corresponding centroids. So, and then we calculate the distance between the centroid to each of the data point. Okay. And then reposition the two centroids for optimization. And then we reposition the centroid from here to here for optimization. Yeah? Meaning that the coordinates where the centroid is most optimized for the distance to each of the objects. The process is conducting iteratively, repeatedly, until the centroid becomes static. So it becomes static. So this is the centroid of the two clusters. This is centroid of the cluster 1, and this is the centroid of cluster 2. That is how we identify the centroid of each cluster. So that is the means. Yeah? When we identify the optimized position of the centroid, it is the means of the cluster. The means of each of the objects. Yeah? The coordinate using the means of the objects. So there are a lot of types of clustering. There will be like hierarchical clustering and partitional clustering. In hierarchical clustering, it is separated into agglomerative and divisive. And in partitional clustering, it is separated into k-means and fuzzy. But on this unit, we are going to talk only on the k-means, because this is the most used of clustering types. Yeah. There are a lot of my projects using k-means instead of the other conglomerative, divisive, fuzzy. Yeah. Mostly my projects is using k-means. Okay. All right. So in the k-means clusterings, we are going to separate the objects into clusters such that each object is exactly one cluster, not several. Meaning that the objective is to separate the objects into clusters, where in each cluster the objects are similar to each other and significantly dissimilar to the other cluster. Okay. Previously, I mentioned that when we are going to calculate the distance. Okay, wait a second. Before I continue, is there any questions up until this slide? Any questions? So far so good? Araso?
Raso.
Okay. So, in order to identify the centroid, we calculate the distance between the initial coordinate towards the objects. There are 4 options onto measuring the distance. There are Euclidean distance, Manhattan distance, square Euclidean distance, and cosinus distance. The distance measure will determine the similarity between 2 elements, and it will influence the shape of the clusters. So, let's say you have the cluster, and then there is cluster A and there is cluster B, and this is ER1. Which cluster does ER1 belongs to? A or B?
B.
Yes, because the distance is closest to the B. So when you have a cluster and there is a new customer come, you can calculate whether he or she belong to which cluster using the distance measure. And in the financial data analytics unit, we are going to focus into the Euclidean distance measure. Yeah? Rather than studying all, we focus on the Euclidean. So we are going to use the k-means, and for the distance using the Euclidean distance. So how do we calculate the Euclidean distance. Euclidean distance is the ordinary straight line method. So we calculate using the ordinary straight line method. It is the distance between 2 points in the Euclidean space. The formula is like this. If there is a coordinate of P and coordinate of Q. So this one is P and this one is Q. Wait a second. This one is P, this one is Q. So this is P1 and Q1. This is Q2 and Q2. Q3. Q2. So how do we measure the distance between this A to B? So the formula is with the power of 0.5 with the square root of P1 minus P2 with the power of 2 minus atau plus minus Q1 plus Q1 minus Q2 with the power of 2. Let's say this one is 1 and 1. This one is 2 and 2. Oh, 2 and 3. Okay. So what is the distance between A to B? If the A coordinate is 1, 1 and B is 2, 3. How much is the Euclidean distance? So the Euclidean distance will be square of 1 minus 2 with the power of 2 plus 1 minus 3 with the power of 2 equal to 1 plus 4 equal to square root of 5. So the distance will be the square root of 5. So 1.1 and 2, this is 1 and this is 2. This is 3, 2, 1. So the distance will be the square root of 5. So that is how to calculate the Euclidean distance. So if we have the situation like this, this is A, B, C, 1, 1. This is 2, 3. This is 3, 1. And here 1 is 3, 2. Okay. Which cluster does ear 1 closest to? A, B, or C? So we need to calculate what is the distance from ear 1 to A, what is the distance from ear 1 to B, and what is the distance from ear 1 to C. Ear 1 to A. equal to 3 minus 1 to the power of 2 plus 2 minus 1 with the power of 2 for with square root of 5. Here 1 to b is 3 minus 2 plus 2 minus 3. 1, 1, square of 2. Here 1 to c, square root of 3 minus 3 plus 2 minus 1. This is square root of 1 equal to 1. So, which cluster does year 1 belong to? Which cluster? Which cluster? Year 1?
C.
C. Oh yes, C. Because this is the closest distance. So this is how we determine which cluster you belong to. Okay? So far so good, Arasto? Capish?
Pronto.
Okay. Alright. So, okay, there is also another measures using square Euclidean distance, using Manhattan distance, square Euclidean cosine distance. So, but we are not going to elaborate more on that. So we are focused on the Euclidean distance. All right. So how does the k-means clustering work in the clustering model? First is we need to identify how many k is that. So we need to identify it using the elbow methods to identify how many k. And then we measure, after we identify there is 2k, and then measure the distance, grouping based on the minimum distance, and reposition the centroids. And then the cluster become matchers. So how to determine the elbow point to identify how many k is there in the cluster? So let's say you have a data set like this. Now the important question is, how will you choose the optimum number of your clusters? The best way to do this is by elbow methods. The idea of the elbow methods is to run the k-means clustering on the dataset where the k is referred to number of cluster. Using the within sum of squares, where it is defined as the sum of the square distance between each member of the cluster and its centroid. So using the within sum of the square methods, we are going to see the maturity of within sum of square. When the cluster is 1, what is the number of within square sum of square? When the cluster is 2, how many is the within the sum of square? For the 3, for the 4, for the 5. So after that, the coordinates will shape a curve like this. So there will be some elbow in here. elbow. When we identify the elbow, we can identify number of cluster. Okay, so in this shape, we identify that the elbow pointing on the cluster using the two cluster. Now we draw a curve. Yeah. So we need to draw a curve within sum of squares and number of clusters. Yeah. Using this formula. Okay. And then we can see the slow change in the value of the within sum of squares after the k equal to 2. So you should take the elbow point value as the final number of cluster. So there is some bracket there or some corner there, sharp corner there. So that will determine number of cluster. And then after that, we measure the distance to, and then point out the Euclidean distance, and then develop the cluster grouping and reposition the centroid to the means of the objects of all the coordinates. What is the means of all the variables? When we identify the means of all the variable, then we identify the centroid that determine the profile of the cluster. So the centroid will be representing the profile of the cluster using the means of their variable coordinates. Yeah. Once the
Can you explain?
yes,
Sorry,
Sachin. Yeah, Irwan.
Can you explain again about the step 4 and step 5?
Step 4. This one.
Yeah.
Okay.
Oh, yeah, this one.
Okay. Let me explain it in another way. So let's say you have the coordinate like age and income. Yeah. So there is age and income. So there is people with the low age and high age. And then same income. So in this cluster, this is the age of 20, 10, 15, 25, 27, and the means of the age is 20. And the means of the income, this is the income is 10 million, 20 million, is 10. So the means is the age of 20 and the income of 10. So we find the centroid of the cluster. The centroid is where the centroid is the closest coordinate, the optimum coordinate, which is the most close to each of the objects. The most close, the optimum position of the coordinate where the distance of each of the objects is the most optimized. So this is the position of the means. This is the k. There is k is 2, and this is the means, the age of 30 and the income of 15, something like that. So this is this cluster. The means of the age is 30, for all of these points, and the income of this cluster is within the average of 15. Compared to this cluster where the age is 20 and the average income is 15. Is that explaining it, Ruan?
Yes, Pak.
Okay, good. So we identify the optimum centroid for each of the cluster, which representing the profile of each cluster. So this cluster, we have 30 people with the profile of age of 20 and the income is around 15. But actually it is not exactly like that. There are age of 10, income 15, age of 27, income 20. But the centroid position is on the 20 and 10. Araso? Alright. So the cluster becoming mature. So this is the concept of our clustering model. Any questions so far? Capish?
So,
Okay. So we are going to go into the demo. Let me share you my screen. Okay. Okay, let me go. Google.com. So I will share you the clustering of the financial ratios, and then I will share it to you. Going public. Save. Okay. Okay, so this is the demo on the clustering model towards the financial ratios. So in the topic of finance, there are financial ratios. Yeah? There are return on asset, return on equity, net profit margin, etc. You name it. Yeah? So the case is like this. You need to identify. You need to identify an industry. Let's say one industry of oil and gas industry. There are 50 companies within the industry. And you need to separate which company is good, which company is bad, which company is highly positively influenced by COVID, positively influenced by COVID, neutral, negatively influenced by COVID, highly negatively influenced by COVID. In order for you to decide whether you want to buy the stock or not. So you want to divide, you want to separate the companies into highly positive, neutral, negative, highly negative. In order for you to select the highly positive companies. That is having the positive externalities coming from COVID. Many company going chapter 11, going bankruptcy. You don't want to select the wrong stocks. So you want to select the right stock. Yeah. So you need to get the financial ratios. How to get the financial ratios? You go to this website in the IDX idx.co.id. Yeah, idx. Okay, let me open this. www.google.com idx. Okay, this one, idx Bursa Efek Indonesia. Okay. Okay, and then you go to the data pasar, the market data. Market data, this one, data pasar, market data. And then you go to the laporan statistical report. Statistical report, this one. Yeah. And then digital statistic data. Digital statistic data. Wait a second. Data pasar, digital statistic data, beta, this one. Okay. Digital statistic data, beta. And then you want to get the financial ratios. Financial data ratios. Okay. Financial data ratios, this one. Financial report and ratios. Okay, possibly this one. Okay. Financial data ratios. Okay, with the latest of March 22. Okay. March 2022. So still loading. Wait a second. Okay. Financial statement is December 21. Okay, submit. So you click to put the March here and then 2022. So the latest financial statement. So we can see that loading. Okay, right. So the data is here. Yeah, plenty of them until 781 pages. No worries. And then let's download the data. Unduh Excel. Alright, financial data March 2022. Okay, save. Okay, let's see what is the data look like. Alright, so this is the data. So, okay, so this is the sector, the sub-industry. Yeah, there is oil and gas, the code of the company, the stock name, yeah, and then fiscal year, WTP wajar tanpa syarat ya. And then this is the ratios of the companies. The total asset, total liabilities, the total equities, total sales, total earning before taxes, profit for the period, earning per share, book value, price earning ratio, price to book value, debt to equity ratios, return on asset, return on equity, net profit margin. Net profit margin. So you can select which ratios you are going to use. Okay, I prefer to use the debt to equity ratios, return on asset, and net profit margin. So we are going to use these three data. So, and then we need to select what kind of sub-industry you would like to select. There are a lot of choice. You can automotive, banks, yeah. Let's say in banks, how many companies is there? Yeah. So if you want to choose the banks, it is, yeah, this plenty of company, okay. Or you want to choose oil and gas, oil and gas, how many companies there? Oil and gas, oil and gas. Okay, ya, Adaro mineral, Adaro energy, then and etc. So basically you need to select this sub industry and select all company and then select the financial ratios. Yeah, depend on your objective. So my objective is to identify the company that is good or bad based on the net profit margin, return on asset, and debt to equity ratios. Just three. You can do 5, you can do 7, it's your call. But I use 3 because to have a better visualization in Python. Okay, so you select this 3. Okay, I select this 3 and then the emitter name. Copy, yeah, and then you copy and then put it in another file. Okay. Okay. And then I have it already like this. So there will be Adaro with the debt to equity ratio, return on asset, and net profit margin. So we have around 58 companies and all of the financial ratios. You can use all ratios, no worries. You can select 3, you can select 5, it's your call. This time I use 3 ratios. Okay, so let's go to the Kaggle. Okay, so as usual, you upload the data. I put the name of oil and gas industry. Yeah. And then as usual, we import libraries. Import pandas, SPD, NumPy, SNP, Matplotlib, SPLT, Seaborn, SNS, color, listed color map, Matplotlib inline, SciPy, import statistic. And then okay. Okay. So after you import the library, we load the data. Yeah. So I use the copy path and then data equal to pd.readcsv and I put the data type, data link here, and then get the data info. So we have 4 columns. You have emittent data, debt to equity ratio, return on asset, and net profit margin for the oil and gas. Okay, that have 57 entries. Okay, and then what is the description of data? So we have data equal, and then data info, and then data describe. So this is counting how many companies there, 57 companies. Yeah. On the debt to equity ratio, what is the mean? 1.27. Return on asset, 0.05, 5%. Debt to equity ratio, 120%. Net profit margin, average is minus 38%. Oh, okay. Minus kah? Okay, this is the standard deviation, 1.86, meaning that from the mean, it goes plus 1.86 or minus 1.86. The same with the standard deviation on return on asset and net profit margin. The minimum number is minus 197 minus debt to equity ratios. Return on asset minus 17%. Net profit margin minus 21%. And the max 12.2, 86%, and net profit margin 1.88%. Net profit margin. Net profit margin is the net profit divided by total sales. So what is the percentage of the margin? Net profit margin. Return on asset is the net income divided by the total asset. Debt to equity ratio is total debt divided by total equity. Debt to equity ratio. We have the data described like this, and then let's display the data. You can use data.head, yeah, or display in the bracket of data. So we can see that this is the emittent, debt to equity ratios, return on asset, and net profit margin. The same like this, yeah, the same. Okay, and then we would like to see we would like to visualize the data using the scatter plot. So let's say from the debt to equity ratio to the net profit margin. Many company is debt to equity ratio below 5, yeah, so there is the data like this. So the data is this is the debt to equity ratio, and this is the net profit margin. And then this is the return on asset towards the net profit margin. This is the net profit margin towards net profit margin. Yeah. So this is to see the this is how to see the distribution of data. This is the ROA towards the ROA, there towards the ROA. Yeah. And then this one is there to there, ROA to there. Yeah. And net profit margin to debt to equity ratio. So we can see the distribution of data like this. You can see the distribution. After that, we add new column into the data set. We add some data of category. That in the data, we add one new column called category, and we give the value of none, yeah, not yet, not any, not a number or not a time. You can put not a time or not a number, whatever, NAT or NAN. And then let's describe the data. So still the same, yeah, the same. And then the data head like this. This is the emittent there, and then there is category there because you already add new column called category with the value of not a time or not a number. Okay. After that, you conduct scatter plot to see the, yeah, most likely the same like a scatter plot on this, like this, yeah, scatter plot, but this one is into more detail using the SNS, not the, this one is using the, yes, same, yeah, SNS. But this one is more detailed, more bigger. So this is using the company name, the emittent name. In here, we only using the ratios, the financial ratios. This one using the emittent name. So we can see the position of the net profit margin. And this one is very low. This is the outliers, perhaps. And then comparing the debt to equity and the emittent. This one is the outliers, I suppose. Okay. And then the return on asset toward the emittent. Yeah. Highly dispersed. Yeah. And then, okay. Let's separate the outlier. We need to exclude the outlier from the calculation. So we need to identify how many outliers is there. So using this is a little bit more advanced. Print jumlah baris sebelum memfilter outliers, and then jumlah baris setelah outlier. So this is the row before the outlier, and this is the row after conducting the outlier separation. This is the standard. We need to calculate the z-score. I think Irwan and Carmelita understand this. The z-score. What is the z-score? The formula for z-score is z-score. Z equal to observed value minus the means divided by the standard deviation. This is the z-score. Let's say what is your observed value? What is the means divided by the standard deviation? Let's say like this. This one is the value minus the means of the data divided by the standard deviation. So 0.55, the z-score number is the z-score number. Okay, so the z-score will be there. Yeah, this one is the z-score. Sorry, this one. So this is the z-score. The x minus the means divided by the standard deviation. This is the z-score. If the z-score, this is the standard scalar. Sorry. Where is the z-score? This one, yeah. So when the z-score is below 3, it's okay. But if the z-score is more than 3, it is outlier. So we identify that the row before filter 57, after we filter with the outlier, so above 3 will be dropped, it is 56. So we identify that there is one outlier in the data. So the number of data reduced to 56 due to the outlier. And then the data described, yeah, on the mean, standard deviation, min, max, and then we are going to do the normalization using the standard scalar. Yeah. We use the standard scalar to normalize the data, and then this is the standard scalar using the z-score 0.277. Is it the same? Yeah. We use the standard scalar using the z-score. And then after that we conduct the k-means clustering. In this k-means clustering, from the sklearn cluster we import k-means, and then the k-means we use the k-means n cluster equal to I, and then max iteration 300, and then random state 0, and then with the inertia append, this is the function, yeah, you can just follow it, and then we identify the elbow methods. So the result will be on the elbow like this. So we identify that the cluster elbow, the elbow will be around 6, yeah, around 6. Okay, so we identify that the k-mean cluster is 6 on the n clusters is 6, yeah, and then we conduct k-means fit onto the new data frame. What is the new data frame? This is the new data frame towards the z-score data, and then the k-means, the new data frame and then we put it on the we set the target of the cluster, the cluster, to fit the cluster, and then we plot the cluster. This is 2 dimension of debt to equity ratio to net profit margin, and then so when we conduct k-means dot fit towards the new data frame dot values, there will be the k-means cluster will be stated in the fit table, the fit label. So we develop the new column called fit for the label, and then the result will be like this. So for this objects of 0 with the data z-score of like this, the cluster will be cluster 3, cluster 1, cluster 0, cluster 1. So this is with the head of 6. If you put 5, will be 5. If you put 0, will be 5. So if you put 57, then it will resulting in 57 emittent. Okay. And then this is for the coloring. For the fit of 0, we want to color with the color number 2, color number 4, color number 1, color number 0, color number 3. So we want to color to colorize the objects to see the separation in the 3 dimension. This is the data. Category. This is the category of color. This is the fit of a cluster. And then let's see the 3D scatter plot. So we import the axis 3D from the MPL toolkit, and then we conduct the X, Y, and Z towards the debt to equity ratio, return on asset, and net profit margin. So there is 1, 2, 3. 1, 2, 3 axis. We put ST is using the standard scalar, for the standard scalar. And then we can see that this is the cluster there. There are 6 clusters. Okay. So this is debt to equity ratio. The more to the right, meaning more debt, less debt. Return on asset. The more to the right is higher return, higher income, higher net income, higher ratio on the income towards the asset, and this is the net profit margin. The higher, the better. ROA, return on asset, the more to the right, better. Debt to equity ratio, more to the left, better. So this is the coordinates. So which is good is here. Low debt to equity, high return on asset, and high net profit margin. This one is the green one. The green one. This is the best one. Okay. And then this is the color palette. There are 0 is red, 1 orange, 2 yellow, 3 lime, 4 dark green, 5 cyan. So this is the 2 dimension on the PLT title, and then this is the 2 dimension of the return on asset and net profit margin using scatter plot. This is the 2 dimension, so just to see within the 2 dimension. Okay, and then this is the display data. Okay, Adaro, debt to equity ratio, and category, and then we move the combine the data using the DFPD pandas concat, using the temporary new data frame and data, and we see that this is the data. This is the old data within the cluster category. This is the standard deviation, the standard scalar data. Yeah. Okay, and then we can identify for whole data. We can see what cluster do they belong to. Okay, this is the data info from the data. Okay, and then we can send the data to our Excel sheets. So data frame to CSV file, put where we want to send the data, the folder of the data, and then we send the data that we can open this file. We can open this file and then select for the cluster 1, what are the company for the cluster 0, highly negative by COVID? What are the company in the cluster 5, highly positively influenced by COVID? This is the SMRU. What is SMRU? This is 5. Very good. Yeah. What are the 5? Oh, this one. CNKO. What is the CNKO? CNKO. Eksploitasi Energi Indonesia. Yeah. This is the company having. Wait a second. We need to identify the best cluster first. Best cluster will be here, the yellow one. Cluster 4 is the best one. Yeah. Cluster 4 is the best one. Cluster 4. So what are the cluster 4? Cluster 4, let's say Apex. What is Apex? Okay, Apex Indo. Apex Indo Pratama Duta. Apex. Let's see the debt to equity ratio 1.69. Oh, okay. We are not using this. Using the data of the standard scalar, ya. Okay. Return on asset and net profit margin. Okay, high, very high, 1.48. Okay. So it depends. If you already normalize the data, you use the normalizing data. But if you use the real data, you can still use the real data. Yeah? It depends on your style, whether you want to conduct normalization or not. So basically, you identify which cluster do the company belongs to, and you can develop your decision-making solution. Which company is highly positively influenced by COVID, which is cluster 4. Which are the company which is negatively influenced by COVID, which is this is the orange. Yeah? So we need to rearrange again the position, the name. Yeah. So this one supposedly 5. Okay, the green supposedly 5, and then we just need to rearrange it again. The black or the orange is negative on the return on asset, and then negative on net profit margin, and then negative on the return on asset. So this one is very bad, the orange one. Where is the orange one? This one? Number 1 kah? No. Number 3 kah? Something like that. Yeah. Okay. So there is. So we coming up with the company name and the clusters. Yeah. So we identify the company and the clusters. Yeah. And then we also need to identify the cluster centers. The cluster centers for 5 cluster. 1, 2, 3, 4, 5, 6 kah? 6 cluster. So for the Debt to equity ratio minus 0.05. This one is cluster 4. 0.26, the best one. And then return on asset 5.8, the average, the means 5.8. And then net profit margin minus 0.52. Okay, minus 0.52. Let me see again. Minus, yes, minus K. Yeah, below 10, below 0, yeah, below 0. So in average it is minus. Okay, no worries. Okay, no worries. So we identify the centroid, the cluster centroid of the 6 clusters. This is the centroid of the cluster. So we need to rearrange the name, yeah. Cluster. This is cluster 4, cluster 2, 3, 1, etc. Depend on your interpretation. If they are low in debt to equity, and then low to return on asset, and then low on net profit margin, it is number 0. This is number, yeah, it depends on your interpretation. This one is identifying the 5 only, 4 only, 3 only, 2 only, and 1 only. All right, that is the demo on the how do we do the clustering on the financial ratios. Up until now, any questions? Any questions on the clustering model on the financial ratios?
It's very difficult, ya, Pak.
Not very difficult.
For me, yes. It's like so many coding. How do we define those 3 of the financial statement, Pak? Is it up to us or is there any rule?
Up to you. So basically people will be looking at the journals. If there are journals that saying this ratio is the most important one. So when you already download the data, and then there are reference on the journal saying use return on asset, return on equity, and price earning ratio. You can do that. Yeah, basically all journals can do. All ratios can do. But there are journals that stated these ratios is more likely important to this industry. Kapis, Nining?
And the maximum will be what?
You can do all of them. You can have 10 ratios. You can have 5. You can have 12. It's your call. No worries. I use 3 only. Why? Because for better visualization. If it is 5, the visualization will be very difficult, yeah? Or 10. There are 10 dimensions. If 3, only 3 dimensions, X, Y, and Z. 3 axes. Very, very easy. But if you put 10, the visualization will be slightly difficult. Okay? Any questions? So I already share the codings, yeah. I already share the codings. You can.
Yeah, Pak, but the data set keep in private, so we cannot try by ourselves.
No. This is already shared public then. Public. You can edit and copy.
I can edit and copy, but it's shown that data set is private.
Oh, the data set. Wait a second. The data set is private. The data set. The data, yeah. What about the data? How to put it? Public kah? You need to public. Oh yeah. I know. How to then? Okay, the data, this one, and then this one. Okay, this one is the data, and then I want to put it, share it, public. Oh, no worries, you can get your own data.
Yeah, okay, we got it.
So I forget, supposedly when I upload it, supposedly I change it to public, yeah. So I need to change it to public. I need to, how to,
Or maybe
to put it
you
public.
can download manually, Pak, and then share to
Share by chat room, Pak, if you don't mind.
Share by chat room. Okay,
Yeah.
okay, no worries. I send it. I send to the chat kah. Okay, chat. Okay, where is chat? Okay, I find the data, library, documents, and then basically you have the data. You know how to download the data, yeah. You know how to download, how to select the data, yeah. So that you can just oil and gas. This oil and gas for kah? Open. Okay, I send it the data already. Cannot send because it is currently in use. Okay, wait a second. I need to close it first. Oil and gas for. I need to close it first. Yes. Oh yes. Okay, and then sending the data again. Oil and gas for. Open. Yep. Oops. Send successfully. Okay, I already sent the data, yeah. Also for the whole data kah? The whole data that I download from the financial ratios. Okay, this one. Financial data ratios cannot be sent because currently open. Oh, okay. Wait a second. Save. Oh, sorry. Okay. Filter. Release the filter. Yes. Okay. Send the data again. So basically you can download the data from the Bursa Efek Indonesia. Okay, I send the data also. Okay. So basically we need, okay. Okay. Yeah. So any more questions on the clustering model towards the financial ratios data? So far so good? Araso? Irwan, are you okay?
I'm so confused, Pak.
You are so confused. No worries. Yeah. There will be options there for the second assignment, whether it is clustering or what do you call it?
E-learning?
No. Super vector machine, neural networks. Yeah. So there will be another 3 topics, and then for the assignment number 2, you can select which one you want to use. Okay. No more questions. All good? Okay, basically guys, you need to do yourself in the Kaggle, put the numbers there, yeah. So basically the second assignment, let's say you put it, you want to select the clustering, yeah. So you need to select the assignment is that you need to select your industry, yeah. You need to select your industry, whether it is oil and gas, or banks, yeah, or a bank. Why not changing? Yeah. Okay. Filter. It's a bank. And then you need to develop the clustering model towards this industry. Yeah. Finding the cluster 1, cluster 2, cluster 3, cluster 4, cluster 5. Which cluster is the best cluster, which cluster is the worst cluster. Yeah, and then you rename it again. This one is cluster 1, cluster 2, etc. Yeah. Depend on the position. Okay. So, and then develop the journals for the clustering result of the banking industry, of the healthcare provider. So how many companies there? Metro Healthcare, Prodia, Mitra Keluarga, Siloam. Yeah. So you select your industry and then develop the clustering on them and see which companies having is the best cluster where you can put your money in, where you can invest your money in. So that is the assignment example, if you want to select clustering and then conducting the clustering. Any questions? No questions? If no questions, then we continue to the presentation of your capital asset pricing model. All right. Yes, Irwan.
Question.
Yes.
So for the number of cluster, we need to determine by
Elbow method.
elbow method by plotting the graph first step.
Yes, and see the corner. It is 5 or 6.
Which corner?
This one, the corner one. This one.
That one.
Yeah. So you need to put here the scale here. You can select the scale to 5, and then you can see, oh, this is 6 ka, something like that. Araso. Okay. All right. Any other questions? So basically, the coding is there. Yeah, you can.
So for the next assignment, you need to choose like three parameter,
My suggestion is this clustering is very good, if you can do the clustering model. But there will be another 2 topics. So if you want to wait and see, you can wait and see. But if you want to do the clustering, you can do it. You can do it right now.
So how many ratio do we need to use? Like 3?
3 is enough.
3 is enough.
So you can have a better visualization, using this 3, you can better visualize it.
So use 3D model.
Yeah, use 3D model. Better off. Okay. The code is there. Basically, you can use the codes and then just change the number. That simple, Just use the codes and then change the number, change the industry, depend on your industry, and then you can get the result and then develop the journal. Basically, it is already done because the code is there already. You can copy and edit it. Yeah. You just need to learn more onto it, more research on the reference. Okay. All right. Cool. Any more questions? No? All right.